And welcome back to another exciting edition of Mr. Hole's Virtual Classroom. Today we're going to be doing it a little different. We're not going to have it projected to the TV, but I do have my trusty sidekick coming in to help today. Again, Mr. Dwight K. Schrute. He wants to step in and talk to you guys today about doing some quadratic functions. Oh, hey, Dwight. Alright, so with that being said, we're going to be all over the place today. But we're going to start on page 241. I want you guys to look, and like I said, the camera footage is going to be probably all over the place, but I figured this will be a little easier for me to do hands-on. That way I'm not having to take it off the screen, and I can show you some things from the book here. One thing I really want to stress right now is just talking about the quadratic function itself. So let me just back this up a little bit so you can see. So, quadratic function, that x is terrible, sorry, is f of x. But like we mentioned earlier, like in 6.1, f of x, it can be p of x, it can be q of x, and you guys are going to see that more as we go through this section here. But f of x, what is it a representation of? So, e equals a times x minus h squared plus k. So we're going to bring that into vertex form, if you will. So our main quadratic function that we used, the actual form, this is a function of the form. What's the actual form? Ax squared plus bx plus c. So this is actually quad form. Let me just try doing it like this. Maybe that'll be a little easier. So this is going to be quad form, and this is a quad function. And I'll put VF because it's going to be vertex form. All right, I want you guys to look on page 241 with me if you could. All right, Dwight, what do we have here for the guys? Well, guys, Dwight, no, move, you're in the way. Classic Dwight. All right, so it tells us we're going to graph g of x equals x minus 2 squared, and h of x equals x plus 3. Same concept as last time about picking test points, but something I want to talk about is this right here. When you see it says x squared, the graph of x squared, when you have x squared, and it looks like it's on a graph, your vertex is always 0, 0, and it forms a parabola going up. Now this is x squared. Now if you have negative x squared, it's going to be going... Sorry, I think I said it backwards. I meant these actually go up to infinity on x squared. And negative x squared, these go down to infinity. So that's just going to help us when we're plotting here in a few moments. So, again, let's take a look back at our references here. It says for us to compare their graphs. Well, first of all, we're going to be making two. You've got your g of x and you got your h of x. So if we were to put that on our t-table, which we can see has happened right here, g of x equals x minus 2 squared. That's our first t-table. And then we got h of x equals x plus 3 squared. One thing that you're going to notice right off the bat is they chose different test points. So why did they do that, you ask? Well, one main reason is they want to see where the plot is going to go. Is it going to be up or down? So if we take our x right here and we plug in 0, 1, 2, 3, 4. See, what they did on this side, they went negative 1, 2, 3, negative 5. Had they have came back up, it would start over. And what I mean by that is, if you went 0, 1, 2, 3. See, this right here is getting you one side. So, it would eventually replicate this. And what it's saying is this is going to go into infinity. The only reason that they chose these particular at this moment is because they wanted our graph to be similar. And by doing so, by picking these test points, and again, they're test points, they're going to be up to you to figure out. You know, these are just numbers that, even from the beginning, that we've picked on our own. And I apologize, guys. I've been eaten up with sinus infection, and I'm struggling so hard to, like, breathe and talk right now. But, so, if we take 0, 4... well, first of all, we got to take our 0, plug it back into what? Everywhere we see X. We got to take our 1, plug it back into everywhere we see X. We got to take our 2, plug it back into everywhere we see X. Same thing here. Take the 5. And what is that getting us, guys, when we plug those back in? That's actually getting us our vertex. Our vertex is going to be the points that lie on the line here. Now, this right here is our x squared right here. If you see, this is your x squared. It's going up. And so that's all it's asking you to do. It just plot all 3 of these parabolas, basically. So by doing so, you can't really mess it up if you actually have... apparently we have some visitors here, but you can't really mess it up by putting these test points. The only reason, again, that these look a little different is because they wanted these to match, all right? So in order how to have the same vertex, you know, like line on the same line, that's why they chose to have -3, 0, and 2, 0. And that's just going to be something that you guys will have to mess around with. It'll be a little trial and error. But we're going to spend a couple days just kind of getting familiarized with this. Alright, so I want you guys to flip on over to the next page, if you will. We're going to take a little look here at example 2 and talk about some of the other comparisons. So, we're doing the same concept here, and it says x squared. So, if we do x squared, what did we say that was? That means our parabola is from right here going up. That's the comparison parabola. Now, it says that we want to graph p of x. Again, p of x could be q of x, f of x. That makes no difference. It's still a representation of y. So, equals x minus 2 squared minus 3. Well, we want to go back and talk about doing vertex form. So, if we have vertex form, we have -2. We want to move that over because what did I say, guys, that vertex form was going to be? Well, vertex form is going to be f of x equals a times, and I'll go back and let you guys see the slide. F of x equals a times x minus h squared plus k. So we need to set it up in that form before we put it into a t-table. So if we have x minus 2, 3, is it already in that form? It kind of looks like it could possibly be. So what we want to do is go ahead and start trying to plot some test points. Well, here we got... the reason they started with 0 just because it's going to be the easiest to find an axis for it. So 0, 1, 2, 3, 4. You know, typically people won't go 0, 2, 4, 6, 8. You know, they'll go into like a coinciding. So, if you will, they'll go 1, 2, 3, 4 as opposed to going 5, 10, 15. Even though it doesn't matter, you can pick any point into infinity. That's not a problem. So if you have 0, 1, all you're doing, you're taking your 0 and plugging it back into anywhere that you see x. If you have your 1, you're plugging it back into anywhere you see x. Because all these are giving you is points on a parabola. And you're trying to find a vertex, which your vertex, how do you know if it's a vertex? Because it starts over. Like what I say when it starts over, I mean like, I want to draw right here for a moment. The first 2 points will probably give you to here. And then it'll start going back up. That's something you'll notice. When it changes directions, how you know where your vertex starts. So, had it kept going down, 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 well, then your vertex would have started the point after it started going back up, or the point after it started going back down. All right, so let's look at example 3 here. And just a quick revisit here, if you will. We've already talked about it, but it says... when the quadratic function is written in vertex form, which we've said, f of x, but as you can see up here, it doesn't always have to be f of x. It can be p of x. It can be whatever. But you're having f of x equals a times x minus h squared plus k. Now, one thing that you're going to be trying to find here is an axis of symmetry. Well, an axis of symmetry is something that divides the vertex, goes down the middle of a parabola. So we'll just take a look right here. An axis of symmetry will be the line that split the vertex right here. So, example 3 says that we're going to graph q of x equals negative 1/2 x plus 4 squared plus 1. Well, one thing that I can already tell you is it's not in vertex form, because vertex form says it has to be what? Negative, and this is positive because it's saying minus. So we want to go ahead and rewrite it as you see here. Q of x equals negative 1/2 times x minus, all right, negative 4, 2, 1. All right. So our vertex, we're able to pull out our negative 4 here. And we're going to be able to pull out our b. So our negative 4 and our b is going to be what we're analyzing here. So our axis of symmetry is actually going to be the negative 4, because the negative 4 is going to be what? Well, let's look at our graph here. If you can see, we're going to go 0, 1, 2, 3, 4. So 4 right here. So the 4 splits on the y-axis. That means it goes right up the center of our parabola. So the axis of symmetry is actually our negative 4, because we went over 4 units, and it's what splits the parabola. Now you can go back and solve for, just to kind of get a good feel of how the parabola goes if you want to use your test points over here. And this is where we got all of our units right here. And again, I apologize, like, the clarity and everything is not perfect by no means, but I figured it might be a little easier just to take you guys through the book a little bit like this.